Hello guys, welcome to Sidza.com. Now in this video we will learn about the molality. This is different than the molarity. We have previously studied about the molarity, but now we are going to discuss about the molality. So there's a difference of L and R, right? Molarity and the molality, and this is how we express the molality. Small m there. The capital M is what we call as the molarity. So what is the molality? Molality basically means how many moles of solute are there in 1 kg of a solvent, right? So it represents the number of moles of solute present in 1 kg of solvent. If you remember, in our last video we have learned that molarity, which is represented by the capital M, it means the number of moles. So if you take here the solute, you got the solute here and you take it in the moles, number of moles of solute, how many moles of solute are present in 1 liter of solution, and that's what we call as a molarity. But molality is the number of moles of solute in 1 kg of solvent, right? This is not 1 kg of solution, this is 1 kg of solvent. Okay, in 1 kg of a solvent, how many moles of solute are there, right? So when you express it, mathematically we can say the molality will be equal to the number of moles of solute divided by the mass of solvent in kgs, right? So I'm going to write it like this: molality will be equal to number of moles of solute, which is NB. As I said, A refers to the solvent and B refers to solute. So this is the terminology that I normally use, right? So when I have to mention about the solvent, I use this term A, and when I want to mention here the solute, I'm going to use the B term. So NB means the number of moles. N is the number of moles of solute, means B, and B is the number of moles of solute here, divided by the mass of solvent, the weight of solvent in kg. So you can say WA, weight of solvent, correct? Weight of solvent. Okay, and this is in the kgs here, right? Isn't it? This is in kgs. So I can also modify this equation like this. I can say number of moles of solute divided by the weight of solvent here. If I express it in the grams rather than kgs, so therefore I need to multiply it by 1000, correct? This is the equation that I need. So the molality will be equal to number of moles of solute times 1000 divided by the weight of solvent. This is the equation, right, that we normally use. Okay, so we can also further modify it, because we know that number of moles of solute, right, number of moles for any substance is basically equal to the weight by molar mass of the substance, correct? Weight by molar mass, and the number of moles of solute, they can be expressed as the weight of solute divided by the molar mass of the solute, right? So I'm gonna change this NB here, but the weight by molar mass. So what I can get one more equation like this: the molality will be equal to the weight of solute times 1000 here divided by the molar mass, right? Isn't it? This is the molar mass of solute. Okay, molar mass of solute time is the weight of solvent, correct, in grams. So this is the equation that we normally use. We can use the first equation or the second equation. And one more point here, this molality, this is a more convenient way of expressing the concentration of a solution, just because you find only the weights, right? We don't see any volume term here, right, in the molality equation, right? There's no volume term. You can see the molality is weight times 1000 by molar mass, again the weight divided by the weight of solvent. So we don't see any volume term here, right? There's no volume term here in this the molality equation. So that means we don't see the volume. That means that the molality will be temperature independent, right? This is temperature independent, right? If you see the volume changes with the temperature, correct? That's why the molarity, can also change with the temperature. That means molarity is temperature dependent term, while as molality is temperature independent. It doesn't affect, right? Temperature doesn't affect the molality. Why? Because we are expressing everything here in the weights, right? So we are not talking about any volumes here, right? That's why the molality is considered to be a better, a more convenient way of expressing the concentration of a solution than our molarity. Now let's take a couple of examples here. Okay. So now let's look at this question here. We got an acetic acid solution. We have 3 moles of acetic acid in 250 grams of benzene. So we need to find the molality of a solution, right? So for this one, I'm going to use the equation number first here, right? Because I got here the the number of moles, right? So this is the number of moles and the weight of solvent. So I'll use the first equation. No doubt, you can use the other equation also, but you have to change the moles into first weight, or if you are given the weight, you can also convert it into moles. So you can use any of them, but the first one here looks a better, a more simpler method, right? So here the molality will be equal to the number of moles of solute, that is NB divided by this is the weight of solvent here in grams, okay, times 1000. Okay, so number of moles is 3 times 1000 here divided by the weight of solvent is 250. Okay, so this is 1, this is 4, this is 12. So 12 grams per liter, right? This is what you get the molality. So you get 12 grams per liter. This is the molarity of a solution. You can say, it is 12 molar. Right? This is a 12 molar solution. Now let's take another question here. What is the molality of a solution made by dissolving 1.45 grams of table sugar, right, in 30 ml of water, and the molar mass of sucrose here is given 342.3 grams per mole. So we got here the solute and the solute in grams, and we got the volume of solvent. We don't have the weight of solvent. See, we know that the molality is what? It is the weight of solute, WB, times 1000 divided by the molar mass of solute. Okay, this is the molar mass of solute into the weight of solvent, correct? So what we are given here, we have been given the weight of solute, which is 1.45 grams times 1000 here, and the molar mass of this sucrose here is 342.3 times weight of solvent. Look at here, we have the water and the solvent here is the water, and we need to change the volumes into the grams, correct? We have to change the weight into grams. We have to change the volume into grams. So how we do it? We use the equation, right? So we can do it from the density equation, because we know the density is actually equal to weight by volume. So that means we can convert volume into the weights and weights into volume provided we know the density. Water, its density is 1 grams per ml. Okay, that means the density of the water is 1. So which means that the weight of 30 ml of the water will be equal to 1 times, that is the density there, right? Density into volume, which is 30. So that means it is 30 grams, correct? So 30 ml of water means 30 grams. Okay, so I can take the density of the water here 1 gram per ml. So it is, that means the weight of solvent is also 30 grams here, correct? So when I solve it, this equation here, it comes out to be 0.141, right? That means 0.141. This is the molality of a solution. This, is the moles per kg of the solvent. Hope you got the concept. Thanks for watching the video. Bye for now.